We're ready for the lesson practice for lesson 10, but before we do that, I brought over this diagram from one of the examples from lesson 10 that just shows how complicated Venn diagrams can be. Notice that all mosquitoes are contained within insects that fly. So all mosquitoes are insects that fly. But not all mosquitoes are female insects, and all insects that fly are female insects. There's these different degrees of overlap. In fact, female insects can overlap with mosquitoes and insects that fly. So we have that region that's all three. And then there's that extra little note. Those are mosquitoes that bite. So mosquitoes that are female are able to bite, and they're also insects that fly. But not all mosquitoes are female. Some are male. Those ones aren't able to bite. And then, not all female insects are mosquitoes. Do you see how I can make conditional statements from this? Now let's take a look at the mosquitoes category that's contained entirely within insects that fly. Because I see that Venn diagram for mosquitoes is entirely contained in another category, I know I can make a true conditional statement. I could say, if an insect is a mosquito, then it is an insect that flies. And that's always true, okay? And again, barring the counter examples of like deformed mosquitoes or mosquitoes that were injured, maybe you swatted them and now the mosquito's dead. Fly now, mosquito. Ha! But you can picture that if we're talking about a regular mosquito, then I can make that conditional statement. If an insect is a mosquito, it's an insect that can fly. I can't make the converse statement because insects that fly is not entirely contained in mosquitoes. They're not identical groups. So if I say if an insect can fly, then it is a mosquito, that's a false statement. You can think of a bee can fly and it's not a mosquito. All right, and if you take a look at, let's take a look at female insects and insects that fly. These are two groups that overlap each other, but neither is contained in the other. What's going to happen if I try to set up that conditional statement? Neither the conditional statement nor its converse are going to be true because you can find counterexamples of both that aren't in the overlap. So if an insect is a female, then it can fly. What about, like, for example, some beetles aren't able to fly. A female beetle that can't fly is still an insect. And then the converse, if an insect can fly, then it is a female. Well, what about a male bumblebee? That wouldn't be in that group either. So that's the counter example that disproves the conditional statement. Conditional statements for like normal looking Venn diagrams that just overlap in a region, you can't say that either of those conditional statements is true. All right, I just wanted to spend some more time with Venn diagrams because Venn diagrams are definitely the friend of the person who's trying to figure out what's going on with conditional statements. All right, let's take a look at the lesson practice. Identify the hypothesis and conclusion of each statement. Oh, come on, Saxon. Give me a harder question. All right, letter A, hypothesis. If x equals 4 and y equals 2, the hypothesis is x equals 4 and y equals 2. Okay, I don't write if, I don't write then in my hypothesis. It's just the statement between if and then. And then the conclusion is the statement after then. 2x plus 3y equals 14. Hey, it doesn't ask me to evaluate the truth of the statement, so let's just quietly move along before I'm asked to solve some equations. All right, letter B. If an apple is a golden delicious apple, then it is yellow in color. Hypothesis. An apple is a golden delicious apple. Conclusion, it is yellow in color. All right, letter C, determine whether this statement is true or false. Okay, so here I have to determine whether it's true or false. If 2 points are collinear, then they are also coplanar. Well, okay, my brain's saying every 2 points are collinear. Any 2 points are collinear. Are they also coplanar? Well, any 3 points are coplanar. So that means that any 2 points are also coplanar. In fact, any 2 points can be contained in an infinite number of planes. Because any line, a single line can be contained in an infinite number of planes rotated around the line. So that means that 2 points are definitely coplanar. This is a true statement. Hey, are you thinking it? Yeah, I know you want to. Let's make a Venn diagram. So let's just see what's going on with collinear points and coplanar points. So if I were to make a large Venn diagram for coplanar points, let's just see what this would look like. Okay, so I'm just going to type in here coplanar points. We'll just write out the whole word. Okay, and now let's say I want to make a separate Venn diagram entry for collinear points. If I could just drag that, there we go. And then we're gonna just rearrange this a little bit. Let's just make it transparent. All right, and let's send this one. Let's see. Actually, I'm gonna just bring this one to the front so I know that it's in front of the other. Oh, I don't have to because it is in front automatically. Okay, so we're gonna say, let's see. Our statement was if 2 points are collinear, then they're also coplanar. So coplanar points and collinear points. Well, let's think about what we just said. All collinear points, if they lie in the same line, they lie in the same plane. So that means that I am going to have to contain this circle entirely within the other circle. I wish there was a prettier way for me to do that. Let's see if I could do that in a nicer way. Yeah, that's pretty good. Okay, so there I have my collinear points. Inside my coplanar points, I can state that if 2 points are collinear, then they are also coplanar, but I would not be able to state the converse because coplanar points are not necessarily collinear, right? We could have non-collinear coplanar points. All right, I just wanted to do that. I know you thought it was fun to admit it. All right, letter D. If x squared equals 9, then x equals 3 or negative 3. Let's find the converse of that statement and determine whether it's true. Well, the converse would be if x equals 3 or negative 3, then x squared equals 9. And is that true? You better believe it. Because if x equals 3, 3 squared is 9. If x equals negative 3, then negative 3 squared is 9. So here's the thing. X squared equals 9 implies values for x. It implies the values for x of 3 or negative 3. So x squared equals 9 and x equals 3 or x equals negative 3 are actually perfectly overlapping Venn diagrams because they're saying the same mathematical thing. Oh man, I just get so excited when doing this because there's a lot of relationships to be found that prove that like the math that we've been doing just makes sense. Okay, letter E. If it is a Thanksgiving Day, then it is Thursday. Well, the converse of that, if it is Thursday, then it is Thanksgiving Day. Hey, today is Thursday. Is it Thanksgiving Day? I tell you what, I'm not eating turkey and cranberries for dinner tonight, so it must not be. This is a statement that the converse is not true, okay? So I'm going to say this first one was true. This one is false, okay? The reason for that is because if I made a Venn diagram of Thursdays and Thanksgiving Day would be contained. It's a specific Thursday, so it's entirely contained within the Thursday group. But there's a lot of Thursdays that aren't Thanksgiving days. All right, and then lastly, if a cardinal is a male, then it is bright red. If a cardinal is bright red, I'm making the converse of this baby. If a cardinal is bright red, then it is a male. That is also true because male cardinals are bright red. Bright red cardinals are males. So therefore, because they are the same category, this one is true. The Venn diagrams would perfectly overlap. All right, that's how you do these. Trust me, the Venn diagram is your friend. You should get used to working with them, and you should do 1 through 30.